this chapter, the most important topic is law of radioactive decay, in which I'll start with a beautiful example here. Okay, so now let us consider this is a tank in which water is present up to this level. Okay, and if you see this here, the rate of flow of water is directly proportional to the amount of water present in the tank. What does it mean actually? If more water is present in the tank, then the rate of flow of water coming out is also be more. As the level of the water decreases, the rate of flow of water coming out is also going to decrease. Okay? So the same thing happens in an element also, in which nuclei is going to decay continuously here. So for example, I am considering an element in which there are many number of nuclei present here. For example, there are some nuclei present here, and these nuclei are unstable, they are decaying slowly. Let us imagine what is going to happen here. So these are the total number of nuclei present in an element, that is N0. And slowly the elements getting decayed. As the time passes, elements are getting decayed. So according to law of radioactive decay, the number of atoms which are going to decay with respect to time is directly proportional to number of atoms present. If more number of nuclei is present, then the more number of nuclei is going to disintegrate or decay, we can say. Just like the water here, if more water level is present, the water comes fastly. As the level decreases, the flow rate of water is also going to decrease. The same thing happens here also. And you are writing a negative sign here because as the time passes, the nuclei number is going to decrease. As the time passes, as the nuclear number is going to decrease, we take a minus sign here. So whenever we remove the proportionality, we will get a constant. So here we are getting a constant, like we call it as decay constant here. So that is minus dN by dt is equal to lambda into n. So just you interchange the values, you will write dN by n is equal to minus, you send to that side, minus lambda into dt. So on integrating, you will be getting log n is equal to minus lambda into t plus c here. Let this be equation number 1. We are getting equation number 1 here. So at time t is equal to 0, the total number of atoms are going to be N0. So at time t is equal to 0, all the nuclei is present here. No nuclei is going to decay or disintegrated. Okay, so disintegration not yet started, decaying not yet started, we can say. So at time t is equal to 0, total nuclei is present, not even a single nuclei has decayed. But as 1 minute, 2 minutes, or 3 minutes, or 1 year, 2 years, as depending upon the problem, as the time passes, the number of nuclei number is going to decrease. So let us see what is going to happen now. So by substituting all these values, you will be getting now here log, instead of n, you will write n0. And here you'll write t is equal to 0, 0 plus c here. This is equation number 2. Okay. So you can substitute 2 in 1. You can substitute the value of 2 in 1. And let us see what we're going to get now. Let us see. So log n0 is equal to, okay. So here substituting 2 in 1 means log n you write like that only, minus lambda into t. Instead of c, you write the value that is taken as log n0. So take this n0 to left side, it is going to become log n by n0. This is going to be minus lambda into t. When log goes to the right side, it is going to become exponential form. So we write now n by n0 is equal to e power of minus lambda into t. Minus lambda into t. If you take this as log n is equal to n0 e power minus lambda into t here. N is equal to n0 e power minus lambda into t. So we're getting this equation. Applying log once again, let us see what is going to get. Log n, log n0, this is minus lambda into t. Minus lambda into t, where t is said to be the total time taken for all the nuclei to decay. So whatever the nuclei present here, if all the nuclei decay, the total time taken is t here. So t is taken as the total number of time, total time taken for all the nuclei to decay is taken as time t. So let us see what is going to get now. So from this equation, it is clear that if you take lambda t to left side, you will be getting log n0 minus log n, that is t is equal to 1 by lambda, and this is going to become n0 by n. Okay, let this be equation number 1, you can say here now, or 2, whatever it may be. So you can take this as equation number 2, already 2 is present, so you can take 3 here now. So let us discuss about what is the meaning of half-life time, or half-life period, which is given by letter t half. So what do you mean by half-life period? In general, the time taken for half of the nuclei to decay is called as half-life time. For example, in this, if half of the nuclear getting decayed, then the time taken for half of the nuclear to decay is taken as half-life time. Then what are the changes we're getting now? So for that you have to consider the same equation, that is the basic equation which we have derived here, n naught e power minus lambda into t. What are the changes we're going to do here? N will become n naught by 2 because half of the atoms, half of the nuclear has decayed. So, and also you can take t is equal to t half. These are the changes we are going to do now. So if these are the changes you are going to do now, let us see what we are going to get now. So n naught by 2 is equal to n naught e power minus lambda into t half. Okay, lambda into t half you are getting. So this is cancelled now. 1 by 2 is equal to 1 by this negative sign gets positive and lambda comes to denominator. Okay, then let us see what is going to get now. So denominators are going to be same. We can write lambda t half is equal to 2. So this exponential form goes to right side, becomes log here. Lambda t half is equal to that is log 2 base e beginning. So therefore t half is equal to 1 by lambda log 2 base e. So we're getting the value of t half here. Then what is the relation between total time t and half-life time? Let us imagine total time taken for all the nuclei to disintegrate is 8 years. And let us take half of the atoms to disintegrate. That means out of this 16, 8 nuclei is going to decay at the time of 2 years. Okay, then how many half-lives are present in the total time? You will get that there are 3 half-lives present, because after 2 years when half of the atoms are going to disintegrate or decay, half of the nuclei is going to decay, then total time is taken as 8 years. Means how many half-lives are present in 8 years? 2 years is half-life, means 3 half-lives are present in 8 years, because half-life is 2 years here. So in general we can write like this, that is, we can write total time is equal to n half-life times here. So total time, the formula is 1 by lambda log n naught by n, and small n t half is taken as 1 by lambda log 2 base e. So lambda gets cancelled here. Log n naught by n, log n naught by n is equal to log 2 base e whole power n. So here log 2 base, here also log base e getting cancelled now. You can write n by n naught reciprocal, which is equal to 1 by 2 whole power n. This is a relation which is important to solve the problems of half-life time or half-life period, what it may be. So finally getting now this equation I'm writing here now, that is n by n naught is equal to 1 by 2 whole power n. Based on this we are going to do many previous year problems later. Thank you very much.